In today's topic of Kirchhoff's law, this is the first question. This is the circuit given to you having two batteries and three resistors, and your task is to find the current through each branch of this circuit. You have to find the current flowing in each of the part of this circuit. So the first thing we do is we apply Kirchhoff's first law. Let us assume that the current coming from the 4-volt battery is I. The current I reaches the junction A, from where it gets divided into two parts. From A, current gets divided into two parts. Current I1 flows into the branch AC, and current I minus I1 flows into the branch AD. Okay, current I1 goes here. What is the remaining current? Remaining current is I minus I1. So I minus I1 goes over here in branch AD. The same current I minus I1 will also be going in the branch DC. So what is the branch DC? What is the current? It is again I minus I1. Now this current I1 and this current I minus I1 both meet at a junction C. At this point, both these currents will meet. They will combine. So what is the current that is flowing back from C? Add both these values, I1 and I minus I1. When you add them, what you get is simply current I. So this again confirms. Okay, for the confirmation you can check that whatever current is going outside the battery, the same current should go in the battery. Okay, now one doubt you might be having is that why I have not taken any current coming out of this 3-volt cell. Okay, there is no need for it. Now in the question I have to select loops so that I can apply Kirchhoff's second law. The first loop I am selecting is A, B, C, A. Can you see? Starting from A, going to B, C, A. So this is loop A, B, C, A. And now using Kirchhoff's second law, I shall apply Kirchhoff's second law to find what are the potentials. So starting from A going to B, which terminal of the battery I am touching first? It is the positive terminal, so I will write plus 4. Now from 60 ohm resistor I am going against the direction of current, so I will write it as minus 60I. And again going through CA, going to the final part, CA, again I am moving opposite to the direction of current, so I will take it as minus 20I1, which will be equal to 0. Okay, rearranging these terms, what I get is this. It is 60I plus 20I is equals to 4. This is my first equation. And now some parts in this circuit I have missed out in the first loop, so I have to include all those parts in the second loop. So whenever you are solving problems of Kirchhoff's law, you have to take care that no part of the circuit should be missed out. Either it should be in the first equation or the second equation or the third equation. Okay, now what is the second loop I am taking? The second loop is this. It is ADCA. Can you see? ADCA. And again I have to apply Kirchhoff's laws. So this is how I apply it. See, the first term is plus 3. I am going from A to D and I am touching the positive terminal of this battery. So I will take it as plus 3. Now because I am moving in the direction of current, this potential has to be taken as positive. Why positive? Because I am moving in the direction of current. So what is the potential across this? The resistance is 200 and the current is I minus I1. So the potential is 200 into I minus I1. This is the second term. And the third term, now after C, I have to go back to A. And this time I am moving opposite to the direction of current. So this potential has to be taken as negative potential. So this has to be minus resistance into current. Minus, what is the resistance? It's 20. What is the current? It is I1. So this gives 0. Now I have to expand this equation. It's like this. Expand the bracket. And now again, solving these equations. This is how I add up the equations and this is how I solve it. This becomes equation number 2. 200i minus 220i1 is equals to minus 3. Now after making both these equations, just note that have we included each and every resistor and the battery in the circuit? Has everything come into either equation 1 or equation 2? Yes, all the active elements in the circuit are being included. So the equations are now complete, and now the task is to solve these equations. You can use any method learned in class 10, substitution method, elimination method, determinant method to solve these equations. We have to just get the values of I and I1. This is the method I have chosen. I'm writing equation 2 as it is, and equation number 1 is multiplied by 11. Why multiplied by 11? So that I can eliminate this minus 220 and plus 220. Okay, so equation 1 multiplied with 11 and then added to equation 2. And when I solve it, this is what I get. 44 minus 3 is equals to 41. 660 plus 200 is 860. And so current I is equals to 41 by 860 ampere. This is current I1. This is current I. Now I will put this value of I in any one of the equations to get the value of I1.